Smart Culture, Mathematics.
Hi math students, it's Caitlin here at Smart Culture Education. Today we'll be looking at inverse functions. For our first question, we're given the graph of f and asked if the inverse of f is the reflection of f in the line y is equal to x, then what is the graph of the inverse? So the first thing I'm going to do is write down the intercepts that are given by our graph. So we know that when x is equal to 0, y is 1, and then when x is equal to minus 2, y is 0. This means that for the inverse, when x is equal to 1, y will be 0, and when x is equal to 0, y will be minus 2. So let's look at which graph fits these criteria. So we can see for the first one, the x-intercept is at 2 and the y is at 1. For the second one, the x-intercept's at minus 1 and the y-intercept's at 2. And for C, our x-intercept is at 1 and our y-intercept is at minus 2. Therefore, our answer is C. For the next question, we're given the same graph and asked to write down the equation of the given function and of the inverse function in the form y is equal to. So we know that the equation of a straight line graph is y is equal to mx plus c, where m is equal to the change in y over the change in x, or rise over run, and c is simply the y-intercept, where x is equal to 0. So for our function, this would be y is equal to y2 minus y1 over x2 minus x1 x plus c, which is your y-intercept, which is equal to 1. Therefore, y is equal to a half x plus 1. The inverse, this will be y is equal to y2 minus y1 over x2 minus x1 x and the y-intercept. Therefore, y is equal to 2x minus 2. Those are two equations. Now it says, hence, complete f of x is equal to, and the inverse of f of x is equal to. F of x is equal to a half x plus 1. Inverse to 2x minus 2. It says to show that the inverse could have been calculated from the equation of f. Let's just write out our equation of f is equal to a half x plus 1. What happens with the inverse is that x and y get flipped around. It's going to be x equals a half y plus 1. I'm going to manipulate this to make y the subject of the formula. First thing I'm going to do is times through by 2. I'm going to bring y to the left hand side, 2x minus 2. There you can see we've gotten our inverse equation. We're asked to explain why f and the inverse are both one-to-one relations. If we take a look at the graph, we can see that for every value of x, there's one corresponding y value. Why it's known as one-to-one functions. Write that out. So it's because every x, only one value, and vice versa. That's hence why it's called one-to-one relations. Question, we have consider the function f of x is equal to minus 3x plus 6. They want us to write down the domain and range. Main, also known as allowable values of x. So here we look for square roots, we look for denominators that could result in undefined numbers, and we just have a simple straight line graph. So x simply needs to be an element of the real numbers. There's nothing that x cannot be. Similarly, for the range, y just needs to be an element of the real numbers. There isn't a particular value that y cannot be. Then for b, we have determined the equation of the inverse of f of x in the form f to the minus of x. So we know that our equation is y is equal to minus 3x plus 6. Like we did in the previous question, I'm just going to flip those around to get the inverse. So you have x is equal to minus 3y plus 6. Simplify, so I'm going to divide through by minus 3. So you have 1 over 3x is equal to y minus 2. And then I'm going to make y the subject of the formula. So you have y is equal to minus a third x plus 2. So they asked us to give our answer in the form f to the minus 1 x is equal to. So that would be equal to minus a third x plus 2. For c, they asked us to sketch the graphs of the functions f of x, the inverse of f of x, and y is equal to x on the same set of axes. So we're going to place our axes over here. We're going to sketch y is equal to x first. So that's a straight line with a gradient of 1, and it has both intercepts going through the origin. Next, for minus 3x plus 6, we're going to have our y-intercept at 6 and our x-intercept at 2. And that line has a gradient of minus 3. And then for our inverse, it's now going to be flipped around. So our y-intercept is at 2 and our x-intercept is at 6. That one has a gradient of minus a third. And they asked us what we notice. So you can see here that f and the inverse of f are reflections in the line y is equal to x. So they're reflections of each other through the line y is equal to x. For d, they asked if f of 1 is equal to 3, then what is the inverse of f of 3? So the inverse of f of 3 is going to equal 1. If you look here on our graph, when the inverse x is equal to 3 over here, the y is equal to 1. So as you can see, it flips around when you have the inverse of a function. And then finally for e, they say when f of 2 is equal to 0, what coordinates lies on the fx and what coordinates lie on the inverse. So for fx, you have when x is 2, y is 0. That lies on fx. And then it'll be opposite for the inverse. So when x is 0, y is 2. Okay, math students, that's the end of this lesson. I hope that helped you in understanding inverse functions.
For online tutoring or additional resources, visit our website, www.smartculture-education.com.
Subscribe down below. It's easy.